For the light sensor part of the project, we created 3 different light sensors, which each detect light from 3 different photoresistors, here, here, and here. When the photoresistors detect light, the red LED blinks, and when it doesn't detect light, the green LED blinks, as so. These 3 will be used in conjunction with the microprocessor on the car to control movement. Also, when the middle photoresistor detects no light, the front headlights come on. Also, the microprocessor will be controlling this buzzer here, as you will see later.
Earlier, we left the LCD of the microcontroller on the face of our inspirational GSI Rhishi. And now when I press the S2 button over here, the car will now be in a functional state. And at this point, this button will be used to turn the motors on and off. And as you can see over here, the red light means that the motors are currently off. And then now on to the interesting stuff. If you move to the front here, the yellow wires here and the blue wires here connect to the breadboard to control the motors. And over here, the green wires are connected to the front switches, which will detect frontal collisions and make the car react accordingly. Now we move to the back. These 3 wires, the orange ones, this one, and this one, are connected to the light sensor array on top, which you have been introduced to earlier, to feed the microcontroller the direction of the light in the left direction, central direction, and the right direction. And again, they'll adjust the behavior of the car accordingly. And finally, when the car is backing up from a frontal collision, it will activate the speaker up here through this red wire. And if we zoom in onto the screen, there's actually a full display that shows the status of the motors, the front switches, the light sensors, as well as the speaker. And this will only be noticeable in the full demonstration, but the software is actually capable of automatic ramping, which will allow the car to move a lot more smoothly with a lot less jerky motion.
Now we're going to demo our project. You can see that with no light source, it moves slowly. Now Andrew's going to direct a light to its right, and it should start turning to the right. And as you can see, it's moving faster. It's following the light until it hits the middle point, where it'll just go straight and forward at a faster pace. Now the car hit a bumper, so it turned into the appropriate direction, and you could hear the sound of the speaker go off. Once it hits the bumpers, this overrides all light sensors, so it does the performance of what it should do when it hits. Now it's starting to move slowly again because there's not much light.